Thank you for your interest in my device. I will give a quick tour of the third generation ThumpGauge working prototype. The ThumpGauge is my patented device that accurately estimates tire inflation pressure from mechanical impulse. It's an instrumented hammer that can instantly tell you the pressure in any pneumatic tire by simply striking the tread or sidewall. This is the Mark III device, significantly optimized compared with the Mark II and the Mark I devices. The ThumpGauge offers significant advantages over existing tire pressure measurement methods, but most importantly, it is fast, it is convenient, and it works on any pneumatic tire without having to even find the valve. ThumpGauge's primary disadvantage is that there are cheaper alternatives, although its speed advantage can easily outweigh its cost in many applications. ThumpGauge works by measuring the impact to tires. Both the duration and the magnitude of the impulse are strong functions of the inflation pressure. This is the latest iteration of the ThumpGauge, the Mark III prototype. The hammer can be ballasted to increase the range of tires with which it can work. The addition of a weight significantly improves the accuracy and ease of use when working with high-pressure tires, such as those on trucks or aircraft. The Mark III uses a 3-axis accelerometer to characterize the mechanical impulse imparted to the tire. It also incorporates a thermocouple, allowing accuracy to be maintained even with significant temperature variations. The interface and controls are minimal, consisting of a 3-way switch and a micro USB port for charging and for programming the hammer. The workings of the hammer are relatively straightforward, consisting of leads from the sensors, the thermocouple and the accelerometer, which lead to the CPU. Included are a Bluetooth radio, the primary CPU for the hammer, and a voltage regulator, which interfaces with the battery. Additionally, there is an antenna located at the top end of the clear plastic section. Now I have a demonstration of how the Mark III prototype device operates. The equipment in this video consists of the ThumpGauge itself, a passenger tire inflated to an unknown pressure, a compressed air tank off-screen to the left, a laboratory-grade digital pressure gauge configured to display the real-time pressure of the tire, and a laptop computer serving as an external display device. First, I will modify the unknown pressure in the tire by venting air for a while. Then I'll add some more back in for a few seconds. Although the gauge is connected to the tire, I have it switched off such that I don't have any idea what the pressure is within this tire. Next, I turn on the ThumpGauge and I connect its radio to the external display device. Once it's on and connected, you simply hit the tire with the hammer. Multiple hits are not necessary, but they improve accuracy. The laptop will run the display program and show the predicted pressure based on the 3 thumps from the Mark III to the tire. In this video, I am displaying several diagnostic graphs that show intermediate steps in the prediction algorithm. A production version of the ThumpGauge would skip this portion and simply show the calculated pressure. The pressure predicted by the ThumpGauge for this instance is 33 psi. Now we check to see if it is right. I'm turning on the digital pressure gauge that I zeroed at ambient pressure about 30 minutes previous. It reads 32.35 psi, which is within 1 pound of the pressure predicted by the ThumpGauge. This is a typical and repeatable result with the Mark III in preliminary testing. Thank you very much for your time. Please send inquiries to tgproductsllc@gmail.com.